Okay, so this is live stream. Doing live, and we have it right, perfectly done. And on my channel, we got this video. It's a live stream again, so it's just like it's not it's not it's just not it's not done. Uh, Sometimes stuff gets hanged. It's not a problem. We got zero views right now, zero likes as well. Let me put the video on live stream everywhere it's possible, and all the groups it should be. Mostly Gemini. What? What are the topics? What are the topics? Harry, bro, ये देखिए इधर है topic. I'm doing the. There's a text you. Wait. Mental youth awareness. Mental youth awareness. Wellness. Yep. Uh, my my Discord is hanged right now. I don't know what to do. I put it in the voice chat. Uh, no general chats over here. I don't know why it's not there. Has to be some general talks, man. Like seriously. Wow. Voice chat. Okay. Hmm. There has to be at least some support over here. General chat. It's not possible. Okay, zero views till now. Let's level up slowly. Let's become. Mm, okay, let's put in general chat on the fusion. I don't know what it'll say. It's just. Mm, it's just like very simple stuff. Uh, so I haven't got any live stream support yet. Let me see. It's all about patience. Okay. How many members do you have on the server? It's just 3 members. I don't know why I'm making that. The faces shows your enthusiasm and stuff. Okay, so it's just it's just about being super smart. So I'm live on YouTube currently. I've got no views yet, no likes, no one watching the live stream. Unfortunately, it's all about being alone, but being strong enough to face that. Okay, let's come to work now. It's the work task we are thinking about. I'm making a chassis which has a lot of stuff on it, especially the ESP and the Raspberry Pi. It is together, and it's a lot of stuff. If I can zoom on my camera, it would be a great privilege. Let me see if I can zoom on my camera. I can zoom on my camera, can I? It's just being The okay, there is no one yet. How do I explain that this work is all real? If I can show my board somehow, I need to put on the camera application on and put on the zooming stuff. Okay, I can zoom in on the camera. Yes, I can zoom in on the camera. So I can show the whiteboard now what I'm thinking of. My ideas are super realistic and they need to be moderated in amounts so that it is all perfectly visualized and easy to understand. So currently, what I think is that uh, my chassis is supposed to have some components compulsorily, a Raspberry Pi, an ESP32 with a black marker, and we need the main part as ESP32, and we have a lot of sensors on our chassis. We have a lot of stuff also. It's quite difficult to put it all in one place. So as per I planned, let me tell you the plan, the game plan, the actual plan using is to actually execute everything. So I put my camera normal now. Just a second, guys. Yeah, done. So as per my plan, we are making an autonomous vehicle. I'll show the process. So it needs computer vision features which we'll get from Raspberry Pi. It will process computer vision media pipe on itself so that we can run it, execute the program. We don't need any external interference. It's just the device itself. Okay. We need real time decision making, which uses serial communication between Python and CD port of Arduino, but we'll be using ESP for that matter. And we also need machine learning for identifying objects. Actually, a task list, I'll just show you the task list. It's a quite difficult one given by great people. We need to follow the line. Okay, it can be very unnatural, it can be very unpredictable how the line will actually be. Okay, it can be just black and white strips, as they say, two parallel black lines, and crossing the lane will be a minus negative pointing, negative marking. So either we'll use the IR method or we'll use the OpenCV method of detecting lanes and calculating the turn accordingly. But I think we should be using the IR sensors, but we don't know the actual distance between the lanes, and that's a big question. What are the two solid black lines and what's the distance between them? These two very important questions need to be answered first before doing anything. And also, one more thing. Mm, it's difficult, but we have to visualize that as well. We cannot decide anything on ourselves because it is quite weird. The track is not predictable. We cannot predict anything. It's just unpredictable as okay. A lot of things are going on, and you need to be really, really sharp with that in mind. Okay, and a lot of stuff is going on. Let me rather be alone than to actually be doing this. Okay, it's not gaming, it's news, it's sport, streams. We're having a lot of live streams as well. Let me see what we are at currently. We need to change some data. We need to edit our live stream, the topic, the detail, category. Let's put it on news. Let's put it on news. Let's put it on sports. I don't know why. It might help because sports is a quite trending topic. You will get in the first recommendations. So when you go live now sports, it is quite difficult, but yeah, you get the live stream. Okay, it's zero watching right. I don't know how the stream is still live. We can do it. We can cross viewers. Hmm. I'll go on my own live stream on my channel. Let me get back to the topic. I'm really sorry to go off topic. So, designing this is a difficult task because we have no idea what's happening, especially after everything is done. Okay, wait. So I'll make you understand what's happening. We have no idea what's happening, especially with this stuff. So I made this small document which has all the requirements of a robot in short, and it is making quite easy for us to understand what's happening. Raspberry Pi will process all the machine learning tasks, and we'll have the task related to motor driving and actuator stuff with the ESP. So we don't need to think a lot. Just the communication between them needs to be established, but that's the later stuff. Let's focus on what's happening right now. We need to complete this task of designing, and this is not easy. I need to make a rough box on Paint, on MS Paint, because before making a rough idea of what's actually happening, we cannot continue further. Okay. So what I'm saying is that it's not quite easy enough to how many components and what all and where we do. That's a different story all by itself. So once you realize that it's all separate, everything is a separate story for itself. You have so many components and where to place what. It's very clueless stuff. Okay, you will be completely mad. It's just my god, how is it possible? Let's come back on track. So, as I was saying, yeah. So we got three viewers on our stream right now. It's quite happy moment of my life. Uh, Let me open YouTube and see if I'm being in recommendation list of live streams on sports. Unfortunately, it's just sports which is being promoted while spread. No one promotes robotics nowadays. It's not that famous now. I don't know why it's not. It's just there because it's there. And also, if I cross 10 views, it will be great. And it is very good. Unfortunately, we don't have much of views and we don't have much of following on our YouTube as well. So we are not in the list of recommendations, unfortunately. But whatever it is, let us focus on what's happening and what is not happening. We have a box. We have a box of Raspberry Pi. This is our Raspberry Pi, and we have, oh my god, what am I doing? We have an ESP32 side by side. This is our microcontroller unit because it has two microcontrollers, one for AI and one for actuators. We have two of them communicating and working together. There is a USB bus established between them, a one-to-one bus. It's difficult to realize what's happening, but let's go with the flow. Okay, then you have this as your outer boundary. Okay, this is like covering for all of that stuff. It's a complete cover for that. Now you have the sensors. Like let's take ultrasonic for now. If this is the front of the vehicle, let's take it to be a square. I'll just redo the square part, the rectangle part. I will take my car chassis to be somewhat this way. Okay, and I need an ultrasonic sensor on the front. I need a camera first on the front because camera is the most important with OpenCV, and we will be most probably using the ESP32 camera module or we'll use USB camera. I believe we should use a USB camera because Raspberry Pi is there and we have the advantage of using USB camera. It has so many USB ports. I'll show you once. We can utilize any of these. Okay. Apparently we have only two USB ports and one Ethernet port and two of these ports for display. Might be for USB as well, but let's take it not for granted. So we will have an option of USB camera, but we will not take it for granted for now. But one thing is sure, we are using that space for camera, and we have ultrasonic sensor for distance management, how much distance it is. Okay, and especially with the parking assist, we have to park the vehicle as per them, as per their recommendation. We have to park it as well. Reverse parking assist. So basically, it goes like this: it turns and it parks like a reverse car. Okay, that's why we are using mechanic wheels. It will help us so much in turning, in parking, in gliding away. It's very easy to use mechanic wheels, and locomotion is quite easy. So apparently, it's a good option. Anyways, so we have to do the reverse parking assist as well. It's a big task. We need to use a lot of sensors. It should enter a designated parking zone using reverse motion. Now, because we have no idea what's happening, we have no idea about the arena, we have no idea about anything, it's just a rough idea, and we have to submit an ideation document. So, I will most probably be making it as an ideation itself and not be too complicated to analyze all of it. Let's simply put a couple of ultrasonic sensors with the color blue on the front. We'll have it on the front, on the left, on the right, and on the back. Let's take it for example. We not put it too much stress on that. We have four ultrasonic sensors to have four direction distance always. Like we have the parameters, how much space does the robot actually have, and after analyzing stuff, it can go and park itself, but that's a different story. Let's have those sensors in there just chilling around. So we have currently placed the machine learning models, like, okay, not hardware, it's software. We have ultrasonic sensors. Mm, I think we have camera as well. Mechanum wheeled AGV3. Okay. Basically, what does that mean is that we have four mechanism wheels which normalize their forces to produce a one vector. It's difficult stuff, but okay. Very simply, the functioning of mechanism wheels is again a quite topic which needs quite research on. All right. So, if you see any image on mechanism, it has a 45-degree incline, and when those forces cancel out, they produce a 90-degree vector, and that's what. Okay, I'll just explain the kinematics. So the kinematics is basically what motion does it suggest. Like it consists of vectors, but let's come simply explain it. All the wheels moving forward will produce a forward motion itself because it has a 45-degree incline. So two wheels producing force in 45 degrees alternately, they get cancelled out and we have a 90-degree forward vector. And same for the two pairs, so we get a forward motion. So if you see this diagram, you will understand a lot about mechanical wheels. There's not too much to be spoken about. So, coming back to the design, let's use the color hmm, gray for the mechanical wheels. One. Mm, okay, we need to copy. Hang on, we need to. So we'll take this mechanical wheel over here. Oh my god, how am I doing this? You take this, copy this, and it's not copying itself. So I'll select and take this to the other side. like this. That's how it works, man. Come on, let's go. So, and you have the two systems again with each other working well. Okay, man, this is working not well. We need to make it work, man. Okay, this is how it works. Paint is getting smarter nowadays. It does not that dumb as it used to be in earlier times. We can move it, it's transparent, it understands how much, which object we are selecting in particular. So we got a full mechanism wheels for locomotion, we got almost everything on the rough idea, the rough understanding of what we're actually doing. It's not about being accurate, it's about being able to develop something which is a kind of prototype. It's not exactly what you need, but it's kind of around what you actually need. Then you need a battery pack. The most important thing in robotics, you need to have a reliable power source. Now, when you use 18650s, it's a very simple concept. I'll not explain much about it. 18650 are huge, space consuming, heavy batteries, and they have low voltage, high current. You understand? So they have a medium or towards the lesser side energy density stuff. But if you see a live lithium polymer battery, lithium polymers are the most beautiful thing I've ever seen in my life. They have high energy density. They can store a lot of it and they can let it go slowly, slowly. They can last longer and they have higher battery life. They have higher life of itself. Okay, if you charge and discharge an 18650 continuously, it will lose its power. It will get discharged faster, like charged very quickly. It will lose the capability to sustain energy. But lithium polymers are way much long lasting. Okay, coming back to the point. Lithium polymers can be used, alright? You are not supposed to be forced to use a lithium polymer, but if I want 24 volts on a power supply, if I use 18650s, it will take me a lot of space. So if you multiply or if you just divide 24 by 3.7, that's the rough amount of batteries we need. That's almost 6 to 7 batteries and huge, huge batteries. And it's a whole battery pack by itself. Instead, you buy a slim, thin, and beautiful lithium polymer battery. That's how you can finish stuff easily. Secondly, the most basic fundamental of batteries is that lithium polymer is safer, it is in package form. You have to handfully, you have to do it manually. Okay, the 18650 battery packs, you have to spot solder it and make it spot welding and just pack the battery and make it yourself. It's all DIY, it's not safe. And I've tried it, I have burnt the system by itself, I almost exploded the batteries. Something chaotic happened. Never mind, it happens. So if I have an example of lithium polymer. Oh, I don't have a lithium polymer battery. Only have lithium ions currently, and they're devastating. Okay, these are the batteries. These are huge, monstrous batteries, and they take a lot of space and they're very heavy as well. You don't use them, you use simpler, much easier methods. So that's how you make stuff work. Okay, you need to use lithium polymers. So I was thinking, if I have a lithium polymer, 24 volt, I have no idea about the battery capacity, but I will think of it. It's ideation. Let's keep it as an ideation. We're taking too seriously. Okay. And secondly, it's a very lonely live stream. No one's watching it. So I'm feeling bad. It's just that you have lesser idea about stuff actually happening, and especially what's happening into those. Okay. In my introduction, okay, I'm really sorry to waste the time because live streams are very boring. Secondly, it's all about being focused. And by the way, I just had a breakup, so I'm broken from inside. I'm just hollow. I'm feeling lonely. I thought a live stream would improve my mental state, but okay, let's see. I'll not take a lot of stress on that. I'll not emphasize more on my battery packages. I would like to emphasize more on the functioning. Okay, and battery will make with the red. Okay, I'll put sufficient space enough for the battery stuff. So we have a reliable battery source. We have a lot of stuff. We have camera module, reverse parking assist. We have LEDs, but we don't need extra spaces and markings for them. We can design it on the spot. We can do holes and charges in the design itself after the rough idea is ready. We don't need to take stress on LEDs right now. The main stress is about developing the shape, the form, the idea, the concept of the chassis. It's not easy. So once you think of that concept, that things aren't supposed to work the way you think them, okay? First, I'll tell you, Arduinos are never meant to be used on projects. So if you are watching this live stream and if you understand what I'm doing, please, it's a humble request. Please don't please don't use an Arduino on your live project. It is a disaster, to be honest, and you will regret it later on. And it will be very regretful to have a slower processing system. ESPs are way faster at their baud rate and processing rate. Arduinos are much low category. They are made for prototype stuff. You cannot use Arduinos in real projects. They are very slow. So please don't use Arduinos. No defaming, but okay, it's fine. You can use for prototyping, but I also have a lot of Arduinos. It's used for basic projects and understanding level. After that, you can make your own PCBs or work on ESPs. That's a more reliable source and smarter way to work. Okay, so we have all the stuff we needed. We had doubt on motor drivers. So if we have the four motors, right? If we have a four motor system, four wheels need four motors, and four motors need four motor drivers. If it is a single channel motor driver, and like the one we have L298 and I think it's L210. It's long time I use them. Let me confirm. Okay, okay. I'm correct. I can never be wrong. I can never be wrong, unfortunately. So it has two channels. It can control two motors at one driver. It has edge bridge, so it explains it all. Okay, we have a lot of options on motors. I would not speak a lot on motors, but yeah, Macadam wheel is confirmed, and the motor doubt is that we have four options apparently. Encoder motor we have 12-volt DC, that the normal motor, the heavy one we use. We have stepper motors and 360 servos. Now we have to research on that a little bit. We have to think of it. So when I look at 12-volt DC motor, it is a very simple two-channel motor. You don't expect much from them, and I had used them last year in my robotics competition. Quite satisfactory result, but not the best. You don't have the rotation counts. You need to mount an encoder from outside. Okay, it's not built-in encoder. It is not built-in stuff. It is quite external and outside base. Next, I had one more weird question. It is very sharp, but if you understand what I mean, it is very smart to know, right? So, what I meant was that you can and you will understand yourself that I was going to say something and I forgot. I forgot it. Man, like, wow. This is weird, but okay. If you use DC motors, you need a lot of stuff. So, using DC motors isn't the perfect solution. You need to put encoders, you need to put a lot of stuff. Then another option you have is encoder motors. I believe encoder motors are quite satisfactory again. They have a lot of complexity and unfortunately they are expensive, quite expensive according to the ranges. Mm, they don't deliver the best output according to the price. Like if you get something like a simple DC motor and an encoder in a particular price, you get an inbuilt encoder motor a little higher than that. So it's not worth it. Stepper motors are accurate, but they don't have a lot of torque. They skip steps when they are too much loaded. They are not able to bear the amount of load. So when I talk about stepper motors, they are having a particular limit. They cannot bear more than that. Okay. After that, they have 49, 39, 40 gears. I'll show you the stepper motor inside stuff. Uh, it's complicated, but okay. I'll tell you in simple terms. Outside has rotor. It's very complicated to understand, but okay, let's try. These eight coils you see, there are phases, and they have 40 teeth outside and 39 inside. So a particular combination of those. Okay, Hriday OP in the chat. So thank you Hriday for coming in this live stream and supporting. No one is here except four people. Okay, it's good. चार लोग देख तो रहे हैं. Anyways, so a particular combination of those coils they produce magnetic effect, जिसकी वजह से वो the teeth align in that position and it comes to that step. ऐसा. And we have micro stepping also. So you have micro stepping as well, जहाँ पे you have four instead of four you have eight steps. So positive negative phases align like that. And there are four input output pins. I'll show you how. Very simple, but it's complicated. Okay, inside a stepper motor, you will understand this gear system later on. But let's not go in that deep in that detail. Simply, I'll explain you. Stepper motors cannot take a lot of load. They skip some steps. They miss the rotation. Sometimes they get stuck in between because of high torque stuff, simply because it doesn't have that capacity. Even if you apply at the highest voltage, it will, at the moment it will stop because the coil has a limit and the coils will get burned. That's what happens. So stepper motor is never the option. Then you have servos, and servos are the most lovely motors. As we all know, servos have gears. Servos work very beautifully. They have no problems working. They have no issues on anything. Okay, they are just too bulky. That's the only thing. If you want a heavy servo motor, it is bulky. You cannot go short on the size. Okay, motor driven system and feedback element. There is feedback element. They have precise control of position, speed, and torque. So it is basically you can simply instruct the motor key. You need to go 27 degrees. Okay, rotate 27 degrees. At that position it will get and it will be stuck over there. Or you command the motor to do 5 rotations. It will do exactly 5 rotations. Okay, so we have all these options. We have a simple DC motor. We have encoder motor, which has a built-in encoder. We have stepper motors, which are not suitable for some situations. If you want to use stepper motors, you use a heavy one. Don't use the light one. See the torque specifications in particular. And servos always they have highest torque, low price, and best compatibility. For my project of RoboFest Gujarat, I'll show the website. So I'm participating in this competition. It is a Gujarat level competition, so quite a huge. Uh, it's holding a big aura itself, and it is quite okay. Simply, this is a big competition and biggest robotics competition. It's already mentioned over here. And what do I say myself? Yeah. They have all these categories. I'm participating in the particular AI autonomous driving bots, and over here in this, I'm making this draft. So once I'm done with this ideation of the design, I can work on the fusion stuff. It's not compulsorily you have to work on fusion first and keep it on the side, do the testing on the fusion itself. Let's design a concept, let's design an idea, a rough understanding of what I'm gonna make, which will be easier to execute thing doing something in the air, which will never be goal oriented. We need to be very goal oriented. This is called processing. This is basic sense. If you are a robotics engineer, you should know, you should be very process oriented. You cannot skip some process just because you think it's not important. So, while working on all of this, I came through a lot of research, and recently, some time back, I did a project, robotic arm. AI based robot. I have Jira. I have the robotic arm. So for my school science fair, I made this robotic arm, which had quite a school aura plus plus stuff. It was a gesture-based robotic arm, which had hand gestures. I could move over the screen. My hand will detect the wrist position and accordingly calibrate the X and Y positions and the pitch of all those axes on that position. X was the rotatory axis and Y was kinematically divided into some subparts. So if this is 45 degrees in total on y-axis, it will be divided into some sections, which will be very easy for the person to simulate. Okay, and I was going to add that feature of distance. Okay, but the hypothetical situation and distance, I'll tell you what. When you are using your hand to okay for some gesture control work and you want to get the distance from the camera, the only thing you can do is to calculate and average out the distance of all your hand points. I think the 27 hand points. Media pipe. It should be 27. Uh, they are 20. How many do they have? It's 20. Oh, it's 20. Okay. I think they should be 20 points. So all these 20 points, you average out the distance between them, which gives you a very simple understanding. Because if you say my hand is over here, the average distance of every point is more. But the problem is, if I close my hand, the distance already is close. Okay, it's very close. So if I put the hand over here and still I put my hand closer, I close my hand, I put a fist, it will detect it will detect it as a far distance, even after being at the same place. So if I have a hand is over here and I close my hand, it will get calculation much far away from the current position. That's the problem. So I did not take consideration of distance, but I did take consideration x and y and my claw. So my hand is closed, the claws were closed at an angle. So I took the distance between these 2 points and did the wrist part, the claw part with this, and rest of all x and y coordinates. So all these task lists were completed by me. I actually designed the robotica myself. I have the design as well. It is very um, Messy design to be honest, but okay, it's bearable. I had tried my best to make a professional robotic arm, and it was a quite successful attempt. So it's I think it's 1 or 4 a.m. I need to sleep now. I'm sleep deprived for real. I need to sleep. I'll just take some more time and I'll go to sleep now. I cannot bear it anymore. I'm literally alive on coffee. I just drank some cappuccino 5, 6 hours ago. Cappuccino is very strong. It makes me strong. Cappuccino works really nice. It has some strength, hidden strength. Oh my god, hand. Anyways, let's come back on topic. So, gesture control stuff I had done, and I used MediaPipe for that. It is quite good. Lovely. We were missing something, and I was talking about that. Right. Okay, motor drivers. Right. So, stepper motors don't need a specific driver. They need digital input. They have inbuilt microcontrollers to decode your digital inputs. How do I explain this? They have PWM pins. They get the pulse width modulation input. They decode the input itself, and so basically you get a high voltage power with high current. See, servo motors don't need high voltages; they can burst. Just give them sufficient current enough, okay? Because on load, when they have heavy load, they cannot work. They actually either the motors get burnt or the gears get you know flared out because of so much forcefully rotating with the motor's force. It's a lot of complications. If you have a metal servo, it's a good benefit. That's what I want to say. So, servo motors don't need drivers. They can work on simple digital inputs from pulse width modulation, but they need high voltage and high current, which you cannot get from the MCU. You need external source, but I will not give the external. It's too complicated. You simply cannot use servos. So I rule out the servos. I already ruled out them. Just explained it to you. Why can't you use servos on robotic cars? We can use them, but if you have time and the complexity of your brain to understand and waste your time on getting the power source high energy density to a buck converter and converting it to a low voltage low current system, then using it on your servos, because otherwise you're going to explode the system. It will just burn in front of your eyes. You'll be wow, wow, what's happening. Okay, servos have damaged. I have damaged servos myself and know how it works. So it's experience talking, not me. Okay. Anyways, so servos are not advisable because you need to use buck converters all the time if you have a high energy source. But okay, servos are ruled out. If you have stepper motors, you need a lot of power for stepper motors. It's again ruled out. You cannot. It's simply using coil systems, and they get heated as freak. They get too much heated because of so many coils and electricity, high voltage to maintain that electromagnetism and the power of the motor. So basically, steppers consume too much energy. Servos require less energy, but they also require some energy, and you need to convert it to buck converter. You lose a lot of energy over there because you use coils 1:2 ratio, 1:3 ratio, whatever it is. It can be variable as well. I'm not telling anything wrong. You can variate the output of buck converters and input of buck converters using potentiometers. That's a whole different story. Please don't take it into serious matters. It's lot for today. Okay, so I'll not use the servos. I'm going to use tables. I have only two options: encoder motors and DCs. Now the thing is that I have encoder motors. I have two of them. I have them. Don't worry. out my skills. One is inside my robotic and I can open it right now. It's too much complicated scenario. Just play the Mario. You can have it over here as well. So it's an RMCS DC encoder servo motor. It is a servo hypothetical because it works on command. It has position control, digital speed control, and analog speed control. So it has three types of controls. You can control it using RMCS built-in library. It is on the website. You can check it out as well. You will never know the torture RMCS has done me, the nights I have destroyed just for the RMCS motors. Nothing here. Because I was new to this concept itself of using encoder motors. Somewhat like this. If you understand what is this, if you can make this work in your first attempt, you are more genius than Einstein for real. Because this thing never works on your first attempt. This thing will get burned, it will destroy your feelings for robotics, it will make you lonely, it will hurt you as well. You will get hurt after using this for the first time. Encoder motors are never supposed to be used by beginners. They need a lot of care. And their drivers, those UART based drivers, they need extreme care. They use UART bus. They cannot have more than two devices, a master and a slave on a single bus. You cannot have more than that. If you connect a whole bus of masters and slaves together, one master, multiple slaves, you are going to destroy all of them, all of your encoder motor drivers, which are UART based. The special thing about my motor and my driver is that it works on quadrature system, so it's quite easy to work it out somehow. And this is not that bad. It is a quite good quality PCB. It has a lot of stuff. It no explain someday later when I have time. Today I'm gonna sleep. I'm gonna lose my consciousness anytime soon. So, anyways, encoder motors are the second last or the second option I'll have for this application of my competition that I have currently. I am gonna use myself personally. I'm telling you for this competition where I have to do all this stuff, and it's just a prototype model, and I have to use four mechanism wheels. If I use mechanism wheels, it will be easier. Fortunately, because you can glide through mechanism wheels as I explained through force vectors over here. कहाँ गया? Right. So once you understand the vectors of forces, how to move it diagonally, how to move it parallelly like this, how to move it front, back, left, right, turning, you understand the dynamics of vectors. It's physics. It's basic physics. Because the wheels are very, very efficiently and smartly pointed at 45 degrees. They can make vectors, they can cancel out each other's forces. It's very, very beautiful. It's wow. Okay, it's just crazy. Whatever it is. So I was thinking to use Macana wheels because they have smartness in them. They're not dumb wheels like simple आगे पीछे घूमे वैसे नहीं. They have smartness. They have 45-degree vectors. They can cancel forces, as I already said. It's easy to use, not easy to use, but it is efficient. Not even efficient. It's crazy to use. Okay, they have friction. They have a lot of rubbing against each other. They cancel out forces. They also have loss in that. They're not efficient. Cancelling out forces needs a lot of effort. This is pulling that side, this is pulling that side. You need to cancel out, they are pulling each other so that it moves ahead. It's not easy. Okay. So you use some energy over there as well. It's nothing as efficient as it. But Bacana wheel is quite smart. So, encoder motors are very expensive. I had expense of 10,000 rupees on those two motors. I have two pairs of them. One pair of them. Two of them in one pair. So two encoder motors and two drivers. It costed me 10,000 rupees, and it's never ever a retire. I'm never gonna buy such a motor ever again because it's headache. I have sent it to repair at least 20 times in the last whole year. I bought it last year in December, and it's 9 months, 10 months, something. It's that time, and I sent it to repair to Robotics, their own office, 20 times at least. That's their condition, and it's actually my fault. Sometimes I burned the MOSFET chips. Sometimes it was my mistake. You know, uh, jumper wires they tangle a lot. Don't work with jumper wires. I don't know why they use jumper wires, but see, sometimes mistakes happen. They short circuit themselves for no reason, and in front of my eyes, the whole circuit is burned. Wow, this is crazy. Wow, how is it possible? So, simple thing. Encoder motor is not a good idea. So, my suggestion to myself, is to use 2L298N H bridge motor drivers and four simple DC motors. And as far as encoders is concerned, we don't need them. We can use time-based calculation about the movement and the motion. It's not always about being accurate as crazy. You are not supposed to be working in a very controlled environment. It's very chill, line following, lane based environment. So it'll all be PID based, proportional integral derivative. If you know what that is. So it's a proportional integral derivative, as I told. It's feedback control mechanism, but it's quite complicated. It has the constants. It has a lot of error to how much solving you have. Proportional is some particular value. Integral has some particular value. Derivative has some particular value. All those have some value, which basically corrects the error of current position to the target position. That's how it works. It's quite brain boggling. Let's not talk about it now. Anyways, so line following is easy. It is possible when you have IR sensors, and IR sensors are supposed to be there when you have line following. Now, the only issue is that the only problem with the line following system, I don't have any idea about the distance between tracks. How much do you think the distance between two lines is? You have no idea. The whole document is just a simple ideation document. They have simply done an ideation. They have not specified any particular information about the competition. So I am completely blank right now. It's wow. So that's how it works. It's simply brain destroying stuff. They are given the field size, they are given the surface. Hmm. Okay. It's not too much, but it is too much, in fact. You have machine markers, you have signals, you have a lot of stuff. It's depressing but happy. It's just about being strong in your worst times because I am live streaming right now because I am broken. मेरा breakup हुआ. I had breakup today at school में. In today's school, I had my breakup, so it's quite understandable why do you think I am in a live stream right now. At 1:18 a.m. You know, a depressed guy who is a robotics geek is trying to explain something which no one wants to learn. But okay, it's fine. Whoever wants to see, it's fine. Okay, otherwise, it's just okay. Someday people will realize, okay, we have to see this live stream, very iconic live stream, whatever it is. Currently, I am stuck at this position. I don't know what to do after this. I just got these designs are placed in somewhere randomly. I have no idea what to do with this. Uh, you could design some part of it, though not everything. Like if you design a sketch on the floor, the axis which I'm talking about right now, this axis has capturing position, and you have some idea about what you're gonna make. We got the restrictions or dimension of the robot. Let us go with the max limits because it is easier to not think of everything. Go with the max limits. We have we have specifications. 18 by 20 width by length is 18 by 20. We can follow 17 by 19. So I'll take a rectangle from the center. I believe it should be very beautifully designed, but okay. So we have this arena, this chassis space in which we have to place everything with the mechanism wheels. Do you realize we cannot put the mechanism wheels in the space because you need at least 3 to 4 centimeter of gap on either side. So if you cut 190 by 60, which gives you 130, which gives you a even smaller chassis. So after cutting out the mechanism wheel part, you have not even some space left for anything else. So my decision is to move the Raspberry Pi. I finish the sketch, I'll put the sketch on showing. What I believe is that I need to move this thing above my Raspberry Pi. I am not in disbelief, but see, sometimes stuff gets too disoriented. Because if I don't do this now, I'll tell you what happens. I don't have space, anything for anything left. I'll stack them above each other. That's my concept. I'm gonna put MCU in one single unit, or even I'll put the whole Raspberry Pi in slanting position entity, and I complete the stuff. So I'll just write down what I need to do tomorrow morning as soon as I wake up, cause we need a lot to work. So current design we have is that I just have a rough, understanding of what's actually happening. Right, I have the red marker now. I'm gonna draw this rough design on my board for tomorrow morning to realize what actually I did yesterday night or today night. It's not even some time left. 3 viewers, thank you for supporting all time. So I have my charges ready over here. It's a rectangle. It's a 17 by 19 or 770 by 190 chassis. Uh, okay, so I have made it accurately as per the aspect ratio of my current charges 170 by 90 or 170 160 because actually I have to cut down a lot of space. 170 130 because we need to put a mechanism wheels 30 of gap. We are keeping for buffer. That's not the maximum. So okay. Anyway, let's continue with this task. That's the space we need um, for all our components to be laxfully placed. So my Raspberry Pi is horizontally. It was horizontally kept. Now I'll keep it vertically for consuming less space. And I put the ESP, the black ESP, in another beautiful place. Okay. So I'll have the ESP either horizontally, just like the Raspberry Pi, and it becomes a whole MCU unit by itself, which doesn't need a lot of pressure. This is an MCU. Raspberry Pi and the ESP gives us a very successfully MCU. We have mechanism wheels as well on all four sides. So we're using mechanism wheels 45 degrees vectors, which produce a lot of noise as well. Though they are noisy, but I love mechanism wheels because they are super good at locomotion. So producing vectors on all these sides, they cancel out, produce a forward vector. Again, this vector causes a force this side, this vector causes a force this side. They cancel out to form a force this side. So all of these rotating in a particular direction will lead to the rotation of the whole wheel, the whole car in a single direction. That's all about locomotion. Now we need to think of motors, and I believe we are using L298N. So we will be using two of them, which is basically one and two, kept side by side. L298N is not a difficult thing to do, not a large thing. It's just small driver with two channels and X bridge, so nothing much. So these two are L299. This is a whole MCU. We have not yet placed some sensors on the camera. So what I decided to do is that this is the front side, this is the back side, left and right side. Okay. On the front side, I put a beautiful camera in front, which has good vision enough. As I said, I can use USB camera. I have a lot of USB cameras at home. If I don't want to use USB, I'll use a ESP camera module. Not a big deal. Otherwise, we have also options, many other options we have, but let's not focus on that. I have a lot of work to do. Then we have ultrasonic sensors. Okay, these are the most beautiful things in the world. They will give you the distance between your robot and the next perpendicular stuff normally towards you. So the distance is normal, perpendicular to what surface you are looking at. Okay. So all this constitutes towards a good robot, but the only stuff which is left to decide is the battery system. Currently using a LiPo battery, LiPo is not safe. It is actually quite safe, but it is very safe. It's expensive as well. So Raspberry Pi, ESP, LiPo, two motor drivers, four DC motors. So you have a quite big expenditure on that itself. So these are DC motors. I don't want to take any risk of using complicated softwares or complicated machinery because it will create more complications in that competition when we are actually developing the stuff. So from my last year experience, let's keep it simple, sweet and short. So this is my current design thinking and how will I go through that flow of brain. Okay, like I had my list made for some particular tasks as well. Let me open that list and decide what I've already done and what components I've already arranged. Chassis is 3D printed. Okay, we are having a case, a different separate case for MCUs, a separate case for motor drivers. Everything is 3D printed. Nothing is buy from online, bought from online source. MCU is ESP and Raspberry Pi 4. Expensive stuff, but okay, we have a budget on that as well. Encoder motors, I'm gonna tell, okay, we're not using anything else. 12 volt DC is fine. It's lovely stuff. Okay, it's just too lovely. Okay, we can win the competition with this ideation. I don't know, it's just too weak. Let's design a stronger one, but it's not achievable. So in the end, you just make it very simple. I got the ideation format as well. I just show you. It's still left to fill, and it's very stressful. So technical, you need to put the design in CAD. Components have to be used. The list of structural components: beam, bushes, shaft, belt. Okay, this is too much complicated. Motion components, we are having nothing else. Enough behind flaps, nothing else. We have no controllers. We have LCD, LED programming concepts. Okay, this is quite difficult to complete in one day prior situation. Currently, I'm not taking stress on anything else. Let me complete my design thinking. I am done with this. I put it on my board behind have a good concept over there. Tomorrow I need to. Okay, it's just today. It's today morning. I need to wake up and continue with the designs, and especially tomorrow, I have my physics preparation for day after tomorrow's physics midterm exam. That's a different stress by itself. But okay, let's forget everything and continue what we're doing. I'm getting off track again and again, and it's not easy. And especially after we were too much dizzy, you were not able to sleep because of heartbreak. It happens. You cannot. It's just. It's quite difficult to go through heartbreak, especially a breakup, and it's not that easy. Okay, like you go through all of that stuff, and it is not easy. And again, talking about my breakup, okay, it's just too much. I don't know if I can go through all of that. Okay. Let's come back on track. So for today, I guess Macadam wheel is decided. We have decided a lot of things. I'm not done with the designing it. Let me just gather all the components required. Just arrange it tomorrow morning. I'll get the Macadam wheel from here. I just need a Macadam wheel to come on. It's just about being. Hmm. We need a 50, 60 or 70 or 80 maximum. Max to max, we need an 80 Macadam wheel. Okay. And let's see this design. It's not bad. Okay, it is perfect. By the way, it is perfect. So I can use these mechanism wheels in my robot. I can implement a lot of stuff by the way. Uh, so for now, let me stop sharing. Let me sleep and get back into form tomorrow morning, and I'll continue with that stuff. If you can see what's happening on the board, I don't know what to do with this lighting stuff. It's just too crazy. It's just too crazy, man. I stopped sharing my screen. It's time to sleep. It's quite late, and my live stream has failed. Unfortunately, no one watches it. But okay, we will keep the consistency on. We'll get more views. We'll get more likes. We'll get audience built up slowly. It's not one day task. So meet you in some other live stream. No videos because it's a live channel. So enjoy the life. Let's meet you tomorrow or today, anytime. If I get time, I'll go for a live stream. Thank you guys. Let's meet you next day.